So I need to get some cookies from Tesco.
Yeah.
Then we need to get a new turtle for the turtle box competition next week.
Yeah, that's one goes well.
And then we need to go to McDonald's, obviously, for dinner. And I'm really hungry, so how can we get to McDonald's quicker? That's the question.
I think what will affect it will be the thing that takes us the longest, the slowest step within getting there to McDonald's. And that's probably going to be getting the turtle.
Yeah, because turtles are really slow walking.
Yeah.
Okay, so if we could speed up the turtle, it would speed up the whole thing, right?
Yeah.
We can apply this to chemistry.
We can. So this is all about the rate determining step, and you use this by finding the slowest step. Then you have to do this by doing the reaction and finding what order your bit is.
Yeah. So the reaction we've got going on is NO2
reacting with carbon monoxide, forming
nitrogen monoxide
and CO2. It's all very exciting.
Yes. Carbon monoxide and nitrogen monoxide are both lovely things.
Lovely things, especially if they put in your chips. So when you determine anything from this, you have to do the experiment and then calculate rate values.
And we did that in a previous video. We'd have a table of concentration values, double sum, see what they are.
Yeah. So we found out that nitrogen dioxide that's a second order, and carbon monoxide is zero order.
Yeah. So carbon monoxide is zero. I'm not going to write it.
Yeah.
And what this means is that this is involved, or two of these are involved in the rate determining step.
Yeah.
So the rate determining step.
Rate equals k lots of this.
Yeah, that's another. You can express it like that. What it means is that you've got NO2 reacting twice because it's second order. There's two.
Yeah.
And what this is going to be is the rate determining step. Now, off the top of my head, I don't know what that's going to create.
No.
Just yet.
But you can sort of work out what the things are going to be by doing all of the intermediate steps.
Absolutely. So this is going to happen, and then because it's a rate determining step, that means there's an intermediate step.
Yeah.
And then we know our overall equation is this.
Yeah, so you want to get to this, and we started this bit. Now we know that CO2 and CO are our final equation, so they must be in the middle.
Yep, there must be. It's the only way. And because CO isn't here, it has to be here.
Yeah.
As one of the as one of the reactants in the intermediate. And as Triv said, CO2 is going to have to be produced.
Yeah, so it must be produced here. So what else could be there? Well, it could be another NO2.
Yep, because we've got two here, but we've only got one in the overall equation, and the way to cancel them is if you have an NO2 on the other side. Now, it wouldn't make sense for NO2 and plus NO2 to make NO2 and something else. That just wouldn't happen. So it has to be here, NO2, and that means that that will cancel with one of those, so you only have one in your overall.
Yeah.
Which means we can fill in this. It's quite a tedious process.
It's not very exciting.
What would we need? We need another nitrogen and another 3 oxygens.
So this would make NO3, which means this top bit must make NNO3.
Yep. And this is called an intermediate reactant, and it's something it's produced in this part and gotten rid of in the second part, so it doesn't show up in the overall equation. Yeah. And as Triv said, that means that must be NO. So that seems there's a lot of deriving in the rate determining step.
But just to give us an overall equation, we have this bit and this bit, which will give that part and that part.
And all this is really for is for saying that this is the part that's going to slow down this overall reaction. This happens really, really slowly relative to that, which is quick.
Yeah, and you can make a mechanism using this sort of idea, but often you don't have to.
Yeah, and that's the rate determining step. So, all done. What I'm thinking is, why don't we just pick the turtle up after McDonald's?
Of course!